So I'm very, very honored to be the chair of this session, and where I really look forward to all the very inspiring talks from our speakers. Before we get started, I just wanted to remind you that we have a very tight schedule, so if you could stick after every presentation to 1 or 2 technical questions and keep your more overarching questions to the end of the session, and if we do not have time to tackle them, you can still introduce them with your mobile phone, and so they will be handled on later on. So it's a very great honor to introduce you the first speaker, Annamaria Anderson. She is currently laboratory leader at the Department of Growth and Reproduction and senior researcher at the affiliated International Center for Research. And she has more than 25 years of experience in endocrine aspects of growth and reproduction. Annamaria, the floor is yours.
Yes, I will present phthalates as an example of how human biomonitoring data have been used in risk management under REACH. And as Karen said, I'm a researcher, I'm not a risk manager, so for this presentation I also got some help from Rikke Dunshil-Humberg from the Ministry of Environment and Food of Denmark, because it really was her and her former colleague at the Danish EPA who did a lot of the background work on some of the proposal for restriction of phthalates. But she couldn't be here, so you have to do with me. So phthalates were introduced on the market in the 1920s, and after the Second World War, the sale of phthalates really increased. You might notice that the y-axis on this figure is logarithmic, and if we look at today, the total or the global phthalate plasticize market of today is estimated to be 5 million tons. So this is a high tonnage chemical group. And yeah, this is how it looks today. And 90% of the phthalate plasticizers are used in flexible polyvinyl chloride or PVC applications. So just some examples could be wires, cables, PVC flooring or wall covers, and a lot of building materials. And if you look at modern houses today and homes today, I think you will find different materials where there are phthalates in them. And they put there also to make these materials durable. And if you build a house, you want it to last for 50, 80, 100 years. So they're put there for a reason. But the awareness of the toxicity of phthalates were actually quite early. This is just a table from a paper already from the late 70s. And I don't know if you can see it, but there's a study in there already from 1945 showing testicular degeneration in rats after exposure to DEHP, which is one of the phthalates. So very early on, there was some indication that phthalates could be toxic to reproduction. But in his old study, it was very high doses used and probably not so relevant for human exposures. But over the 90s and the early 20s, more and more data accumulated and showed that there was indeed reprotoxic effects of phthalates, and some of them I would say, not all of them, and also that some of them were toxic to reproduction through an anti-androgenic mechanism. So because of this, there was also then indications, should we start regulate phthalates? Should we worry about how we use phthalates? And what I'm going to tell you now is the story of phthalate regulation in Denmark and in EU, and I will say primarily on these 4 phthalates, because there are many phthalates, and it's not all that have the same activity, but DEHP, DBP, DEBP, and BBP are those phthalates that have been shown in numerous animal studies to have adverse effects on reproduction. So already in 1999, there was some action going on, and there was some first temporary restrictions. And in 2007, we in EU got a permanent restriction on use of these phthalates in toys and childcare articles. So that was the first really restriction in the EU. And then these compounds also were added to the candidate list of substances of very high concern, the 3 of them in 2008 and followed by DEBP in 2009. And based on this concern, Denmark made a report on the combined exposure to children to these phthalates. And in this report, they used 2 approaches. They modeled the exposure to children, and they also used some human biomonitor data that was available at that time. And the conclusion of the report was that the combined exposure to phthalates were in some children so high that they could not be considered to be without risk. And this was also given as an input to the Council conclusions on combination effects of chemicals. And Denmark then also took action on this report, and they notified EU that they wanted to do a national ban on these phthalates. And at the same time, Denmark sent a restriction proposal on these 4 phthalates to the EU. In the meantime, these 4 phthalates had been added to the authorization list on the REACH, again due to their toxic effects on reproduction, and it had given a sunset date in 2015. Well, in Denmark, we got a detailed opinion from the EU Commission on our national ban, and were told that it was really not a good thing to make a national ban and at the same time make a proposal for a restriction in EU. We should rather wait for the outcome of that restriction proposal. And ECHA gave a negative opinion on that proposal and had a negative opinion on an EU ban on this 4. And the main reason for that was that the Danish report, which was the background for this, they said that the data that this report was based on was too old, because they were based on data from 2008 and older, and we had already made some restrictions in 2007. So maybe the levels that were in the report were not reflecting the current exposure, because maybe the effect of the restriction had led to lower exposure to children. So that also shows the importance of having really new data very quickly. Well, Denmark lifted their ban and also proposed to include the 4 phthalates on the candidate list as endocrine disrupting chemicals. Now, in the meantime, Democopus has started, and for those who don't know what Democopus, I don't know if anybody does know what Democopus is, but it's an European project trying to standardize human biomonitoring in many different countries in EU. I'm not sure exactly how many, but more than 12 countries. From that, they collected samples of children, and there were measured also phthalates in these samples. And of course, things take time. So at around 2014, we knew that there was some data, but they were still not public available. But the preliminary indications was that maybe children were still not And ECHA then asked Denmark to make a joint restriction proposal on these 4 phthalates. And they contacted Democopus to get these new data, because what we learned from the first restriction proposal is we need new data that is collected after some restriction has already been put in place. And they got the data, and these data were then part of the background dossier for the proposal, which was submitted in 2016, and I can reach to today. In July 2018, the Reach Commission supported the phthalate restriction proposal. So just a bit about the background and the justification for this restriction proposal. Well, one thing is that there was a clear hazard identified. We have a lot of animal data showing dose response for adverse reproductive effects in animal data, and also some epidemiological data supporting this. We know that the use is widespread, and we know people are exposed to these chemicals, and children have many different exposure routes are included, both oral, inhalation, and dermal. And in this new background material for this, they again used 2 approaches, both a mathematical modeling of the exposure of the children, and then based on especially the Democopus data, they could also calculate back what was the daily intake of these children, and calculate risk characterization ratios. And the background here document can be found on ECHA's website. So if anybody would look closer into that, it's available. So just a little bit to look at the data that were made available from Democopus. And this is looking at the risk characterization ratios, which says something about is a level safe or is it not safe. So if it's below 1, it's safe, and if it's above 10, it's an indication that, well, maybe the levels are not safe. And you can see the levels in the mothers and in the children, and what's highlighted here in yellow are in all the countries what the RCR was above 1. And you can see for some of the single phthalates, there were some countries where actually were above 1 at the 95th percentile for just a single phthalate. But if you also look across and the combined exposures of these 4 phthalates, it was actually 14 out of 15 member states where more than 5% of the children were at risk. And in this background material, they also tried to project these data into 2014, and it was the same. And if you combine all the countries and looked at the different percentiles, especially for the children, you can see that already at the percentile 90, you have an RCR about 1. And that means that in the Democopus data, it's indicated that more than 10% of the children in the EU were at risk from the combined phthalate exposure in 2011. And in the projection estimates they did, they estimated that 5% of the newborn boys in the EU in 2014 were at risk through the in utero exposure from the mothers, and about 15.5% of the boys were at risk from direct exposure. So what did they learn, the risk manager learn from this exercise? Well, biomonitoring can be give a significant contribution to exposure estimates, but it needs to be a sufficient high number. It needs to be reflecting the general population and be of a good quality. One drawback is that human biomonitoring in itself does not say anything about the source, which you also want to know if you want to manage exposure. And it's also important that you know something about the toxicokinetics of the compounds, because you have to calculate back to an intake. So, and also, I was told to tell this, it was actually quite difficult to get these Democopus data because they were not public available at the time. And that's often something we see. We want to publish things, it takes time to make way, and then very often maybe the data is over. So the take-home message for my partners here in this from the Danish EPA is that regulation using biomonitoring data requires that we know about the toxicokinetics of the substance, and they must be carefully designed and reported quickly. And I think in human biomonitoring for EU, we are addressing all these. We have pillars looking at also toxicokinetics of the compounds that we're measuring, and as already been said, there's a lot of emphasis on sharing the data and sharing the data timely. So what happened with phthalates? Because we have a little bit of some trend data, and this is not from children, but from young Danish men. And for the metabolites of DHP, we can see a clear decline from 2007 and just a few years after, so something is going on. In Germany, the second column, or the second cluster of columns, which is a metabolite of DBP, you can see that there's a huge decrease already from 1993 to 96. So there also seemed to be a decrease even before we implemented regulation in EU. And that might indicate that industry producers are actually quick, or maybe even quicker than the risk manager, to pick up on that here could be a risk. So that's a good thing, I think. And again, in the US, there's less indication, but maybe they are slower. We heard we were better. Oh, maybe it's dangerous to say, but yeah. And I think that's what I have. Thank you for listening. And again, if you want to see more about the background dossier for the restriction proposal, you can find it at the ECHA's website. Just search for the annex, or there's a bit.ly short version of that.
Thank you very much, Annamaria. It was a very nice and clear presentation showing that HBM results can really have a concrete added value for chemicals regulation. I think we can give her applause, no? Are there some technical questions from the audience, burning technical questions? I have one at the back. I don't know if there is a micro.
Yeah.
Okay,
Yeah.
Behind you, sir.
There are three scientific opinions from, under Commission scientific committees, and Skinner gave its last opinion in 2015, and I just read the clinical and epidemiological evidence, and there is nothing on DHP.
I think it's just a comment that you wanted to make, no? Thank you very much. So, thank you, Annamaria.
Yeah.
Then we can continue and go to another speaker. I'm very proud to be able to introduce Marco Martuzzi. He's an epidemiologist with experience in environmental and occupational studies. And he has been working over the last 15 years at the WHO European Centre for Environment and Health. His current work is concerned with the health impact of several risk factors and health determinants. The floor is yours.
Right, thank you very much, and thank you so much for the kind invitation to this meeting. I'm really pleased to be able to share with you some ideas and some of the work that we've been engaged on in WHO relating to human biomonitoring. And I'll focus especially, I'll start from the general perspective, but I'll focus especially on a role of human biomonitoring responding to local contamination. I come from the European Center for Environment and Health of WHO, which is based in Bonn, in Germany. Just to remind you, the Regional Office for Europe of WHO covers all EU, but also a lot of other countries to the east of the geographical continental Europe, down to Central Asia. So we deal with a really diverse set of member states with very different needs and priorities. For us in WHO, in the European Center for Environment and Health, the main reference framework for our work is the European Environment and Health Process, which is an initiative that goes back to the 1980s, where we have been promoting work with our member states to bring together essentially the two sectors, environment and health, plus a number of other actors, international agencies, and other stakeholders to address the priority in the area. And over the years, the process has had main landmarks in the ministerial conferences on environment and health, the last of which having been last year's Ostrava conference in the Czech Republic that took place last June. And in the Ostrava conference, member states and other stakeholders and actors agreed on the identification of several broad areas as priorities for environment and health. And you see them listed here: air quality, water quality, chemical safety, waste and contaminated sites, climate change, cities and regions. And I marked the first four in red because, of course, it's obvious the relevance of HBM is pretty direct. And clearly we stand to benefit for further progress on these areas as HBM improves and becomes more strongly established throughout Europe. So I certainly don't need to tell you that there's an obvious role for human biomonitoring to provide the hard evidence of environmental pressure on human health. We heard a lot of that this morning. We need, of course, to ensure to get information on variability of these pressures over time and space, and HBM is ideally placed to provide that sort of information. We also have a strong need to integrate and harmonize data at the European level. This is, of course, for an agency like WHO, an essential need. We see that good HBM data and initiatives stimulate policy response. Once you have information and numbers and distributions of people's exposures and doses to contaminants, the policy response is much more stimulated and promoted. There's also a function, I think, in stimulating further, more focused type of research. HBN can really help steering research in environment and health towards more profitable directions. And we invested quite a bit of work on this issue on identifying the environmental health research agenda in Europe. And clearly, you saw the topics coming out of the Ostrava conference, and there's a lot of complexity to be dealt with. We include issues like air quality, which have a very strongly established tradition in research. There are individual contaminants under examination, but there are also broad issues like the one I'm expanding on today, like waste and contaminated sites that involve phenomenal mixtures, and we heard a lot about that as well, and often very uncertain or suggestive evidence. So this complexity is clearly one of the challenges in this broad agenda. And HBM can really play a role to help address and embrace this sort of complexity. The role of HBM is not certainly, the importance is not something which we're discovering now. Already in 2015, in one of the events in the process, we prepared a publication on facts and figures on biomonitoring. By now, it was 2015. I guess by now it's fairly out of date, but this is to say that it's really one of the issues on the table at the time of it was the midterm review of the European health process in Israel in 2015. Moving a little closer to the topic I want to most discuss. One bit of the Ostrava Declaration. The declaration is the main outcome, politically speaking, of these ministerial conferences, where the 53 ministers of health and 53 ministers of environment undersign a short document outlining the priorities and the main goals in environment and health in Europe. And one part refers to preventing and eliminating the adverse environmental and health effects, costs, and inequalities related to waste and contaminated sites in the context of a transition towards circular economy. I take the opportunity to inform, I'll come to waste and contaminated sites, but we're also paying attention to this broader context of circular economy. We published recently a report on circular economy and health, which is available online. We are further working in this direction to really try to clarify the implications for health in the transition towards circular economy, which has been, it's a very rich and lively debate, but we felt that the health community or the health dimension has been somewhat underrepresented so far, and we want to really try and ensure that the health considerations are right at the center of the important policy debate. More on waste and contaminated sites, more specifically, and again, this is taken from the Ostrava outcome. The outcome includes points for action in environment and health, and when it comes to waste and contaminated sites, you see here a set of points, which include work on human exposure and monitoring, the identification of priority sites for remediation and phasing out, which requires a lot of further information. I also highlighted better monitoring exposure to hazardous chemicals and risk assessment as one of the main functions of this type of initiative. Contaminated sites are a rather big deal, I suppose, for public health in Europe. The great work of the European Environment Agency over the years has periodically updated the inventory of contaminated sites in Europe. There are hundreds of thousands of them in EEA countries. And of course, there would be many more if one could consider the countries to the eastern part of the WHO region, but those are not, unfortunately, those are not counted. And the agency also provides information on the type of activities that produce these contaminated sites, and you see here how the sharing of the sources is, with the main activities having to do with industrial production and commercial services, the oil industry, and there's a lot of contaminated sites due to waste, both municipal waste, hazardous waste, industrial type of waste. The agency also provides information on the type of contaminants affecting soil in Europe, and these contaminated sites are mainly linked to the notion of contaminated soil, even though, of course, contamination of water or food, local food systems is pretty much of high importance when it comes to health effects. And here you see a mix which is probably familiar, which includes a lot of contaminants that have been intensively studied over the years. And I think all of them are part of the current work of a project like the HBM for Europe project, and we saw the priority list earlier on. We've been working on contaminated sites and health for many years in WHO. There's quite a lot of evidence, but it's very sparse. To make a long story short, there is this big problem. We don't know much about the health implications. We don't really know what the likely health impact is across Europe. But we know, on the other hand, that the many sites, the hundreds of thousands of contaminated sites in Europe, 6% of the people live within 4 kilometers from a landfill, for example. And they are really ubiquitous, and it would be really good to try have a go at describing, at least in a first approximation level, the kind of likely health impact of these sites. So when it comes to local contamination, I was thinking that we can try to identify 3 levels of application and interaction with HBM in studies of local contamination and health. One, when the entry point is a certain contaminant. One is when we're trying to estimate the presence and magnitude of a possible health effect. And third, a health impact assessment, which is very an important issue when it comes especially to policy. So at first level, I want to give you an example of a project that we've been running with the United Nations Environment Programme for several years. It's the development of a global plan on mercury. This involves several agencies. It's a global project where we are engaged with several other partners. And there are these sites across the world where mercury is considered, and it's a framework force of the Minamata Convention. There are 2 sites in Europe, in Russia and Kyrgyzstan, that we are especially involved with. And all these sites, the focus is on perinatal exposure to mercury. There are approximately 250 women per country, mothers delivering in hospital. We have standard operating procedures and standard survey protocol. And this activity also involves quite important work on capacity building, because many of these locations really can benefit from more capacity in running the surveys, analyzing the data, interpreting the result. So it's a very core activity, again, when the entry point is one substance, as is the case here. A second level, as I mentioned, is human biomonitoring to essentially in epidemiology. When it comes to estimating health effects of contamination, of local contamination, and a good example taken from current work is an interesting story on PFAS contamination in water. It's one of the several stories that are emerging in recent years. The Veneto region in Italy, in northeastern Italy, in a local area, they discovered a few years ago important contamination of their drinking water from PFAS, from an industrial source. And the response was remarkable. The health authorities of Veneto, the first response was to put in place filters to remove most of the contamination from water. But then in the follow-up, there's quite some epidemiological work and some biomonitoring work as well. We described the story from the beginning in a publication that I invite you to look at, which is, as I say, a very nice public health story, I think. But specifically, currently there are studies underway, and one which is about to be, or two, about to be published, refer to reproductive outcomes. Essentially, people in the area looked at contaminated area versus an unexposed nearby area, because contamination is very localized. And they found, they are finding, they will be publishing soon, quite visible effects on low birth weight and pregnancy complications and a few others. And it's rather convincing evidence because the risks are there for a very large sample of births. And they kind of disappeared, almost disappeared after the filters were put in place in 2015, I think it was. Yeah, I'm almost done. And so we tend to think in epidemiology that this rough comparison of an exposed area and unexposed area involves quite substantial exposure misclassification. And typically this misclassification produces a dilution, a regression to the mean, a correction of the relative risk towards the null. Surveys are underway in Veneto to do biomonitoring of PFAS in local people. It will be very interesting, and we really look forward to seeing what it happens when you, rather than comparing the exposed and unexposed, the red and the green areas, as it were, when you look at the data from people's contamination. Finally, the HBM for health impact assessment. And for us, of course, it's a special case in that health impact assessment is key for policy, as we heard already this morning. We are working, for example, on waste when it comes to vicinity to waste facilities like old generation landfills that are very problematic. We deal with relative risks generated in black box studies, looking at vicinities. So what's the correct, I mean, the question is really fundamental, what's the correct exposure there? Even if you had the possibility of running surveys, what would you really need to know? And it's not an easy, there's no clear answer to that, and I think that HBM can be useful for defining relevant exposure metrics and profiles, especially when complex mixtures, as it is the case for waste, are involved. And it's been touched on this morning, the issue of communication and ethical values is fundamental. So I'll finish there. I'll put in the slides some, which I understand that will become available after the meeting, some links to some of our publications on the topic, and thank you very much for your attention.
Thank you very much for sharing your insights in a more global added value of HBM. Are there some burning technical questions? If not, thank you again. Then we can move to the next speaker. I'm very honored to introduce you Catarina Magrilova. She's a program officer since May 2007, where she coordinates the effectiveness evaluation of the Stockholm Convention. She's also managing the program on minimization or elimination of unintentional release of POPs under Article 5 of the Stockholm Convention, and she's a scientific and technical expert of environmental protection. So, the floor is yours.
Thank you very much for this opportunity. I'm representing the Secretariat of the Basel, Rotterdam, and Stockholm Conventions, and we are very happy to be able to present the outcomes and experiences with the global human not only human, but global monitoring plan under the Stockholm Convention in this audience. Just very briefly, the Stockholm Convention on Persistent Organic Pollutant is a global, legally binding instrument to protect human health and the environment from persistent organic pollutants. Just to remind ourselves, this group of substances has been considered of the greatest concern because of its properties, because they are travel through atmosphere, through water, through species, and get dispersed through the globe and find their way even into the very remote areas where they have been never used. And on the top of it, they are bioaccumulating and bioconcentrating through the food chain and enter the bodies of humans and other living species. So because of this, a global treaty has been adopted in 2001, entered into force in 2004, and currently this treaty has 182 parties. These parties committed to adopt and implement measures to eliminate the production and use of intentionally produced persistent organic pollutants, or POPs. And those are listed in Annex A. Then there are a few of them which are only listed in Annex B for a restriction. And in a very restricted manner, they are still used. DDT is one of the examples. But of course, the intention is to eliminate them at the end if feasible alternatives will be available. Then there is another group of substances which are unintentionally released, and those there a set of measures is available, and the parties committed to implement them to reduce or, if possible, eliminate their releases. From these substances, currently 28, 15 are pesticides and 13 are industrial chemicals, or at the same time, some of them are at the same time also released unintentionally. So it's a relatively small group of substances when we consider the thousands of chemicals which are on the market. I am here to talk about the global monitoring plan. And the purpose of this global monitoring is to evaluate the effectiveness of the treaty. And right in the Article 16 on effectiveness evaluation, it has been already established that a harmonized framework for collection of comparable monitoring data on POPs has to be put in place in order to identify trends in levels over time. And of course also to provide information on the global environmental transport. So the whole monitoring program is designed to answer this question: are the concentrations in humans and environment decreasing or not? So we are not looking at hotspots, we are not looking at risk assessment. The purpose is purely to be able to say whether the treaty is efficient and the concentrations are going down. There are only 2, or now also 3 media which we are focusing at. One is ambient air, and here I have to say again, it's more the background air, which is not influenced by some local source. And then this is combined with, this shows a bit of immediate response to situations. For example, what we can detect is major events such as, for example, huge forest fires where some of the persistent organic pollutants can be released again to the environment, and then we can detect a sudden increase in concentration. And this is combined with human biomonitoring, and the media are human milk or blood. And this medium is showing the exposure over time, and because of the property of POPs that they are bioaccumulating. Here I would like to stress that we are focusing only and entirely on human milk from first-time mothers. Because if we want to detect truly trends over time and see and compare one generation against the next one, normally the distance between the surveys is about 6 years. Then we have to look only at first-time mothers because maybe you know when you are working in biomonitoring that the release of these substances from the human body is going through the human milk, and when a mother already had 2 children, then her contamination will be much less like when she was breastfeeding the first child. And why I am stressing it is because there are many valuable surveys of human milk monitoring, but there is no distinction whether the mother had 1 child or more. And these data are basically not at all useful for our purpose. So I just use this opportunity to stress this. Sometimes we are very unhappy that we just can't use the data because we don't know whether this has been considered. Now I listed also water, but this is purely for perfluorooctane, sulfonic acids, and probably also the further fluorinated substances which are water soluble will be monitored. Water will be the medium for them to be monitored. This is a global survey, and this, of course, the harmonization and cooperation on global level of everybody who is involved, all monitoring programs which are involved, is of utmost importance. Therefore, we have a guidance document which has been developed by experts throughout the planet who are involved in this type of monitoring. And I must say that in the more than 10 years of existence of the Global Monitoring Plan, a lot has been done to harmonize approaches and to agree on details such as how do you present your data, because it's purely mathematics, but sometimes you just can't compare. I don't need to go into details. So yes, but this concerns mainly the air monitoring, where many programs have been involved. There is a regional structure in place. This monitoring is official monitoring under the Stockholm Convention, and the parties have the ownership. So any monitoring program or any expert involved has been officially nominated, and all data published in the reports I will show later are blessed by the parties. So they are politically accepted, which is very important because, again, you can find a lot of monitoring data from various places, but not always these data are considered by the governments as truly representing their country. So what we are publishing under the GMP, the Global Monitoring Plan, has been approved by the governments. The results which have been achieved so far have been published in 5 regional monitoring reports, and these regional monitoring reports are always integrating the results which have been already published before, and then these reports then are integrated on a global level. So we have a very detailed regional report, and then there is a global report which is looking at the information from the global perspective. Very briefly, in this short time I have available, what are these data telling us so far? Is 2 major messages. One I would say is bad, one is good. We can truly say that the presence of POPs on our planet is ubiquitous. We find them everywhere in measurable concentrations. Whether it's in the Pacific Islands, where a small island is lost in the middle of the huge ocean, whether it's in Europe, whether it's in Latin America, whether it's in developed countries, whether it's in developing countries, in Africa, everywhere. Of course, we all know that we have a lot of them in the Arctic, where nobody would expect them some 20 years ago. So they are everywhere. The good message or the good news is that it is very clear from the monitoring data and from the trends over time that if measures are implemented to reduce or eliminate releases of POPs, the concentrations in both in humans and also in environment are decreasing. So this is good news, and we know that when the measures are truly accepted or implemented globally, we will slowly, but we will clean up the planet. Further, as I mentioned, the Global Monitoring Plan has been established in the first place to provide input for evaluation of the effectiveness of the Stockholm Convention, and only recently the effectiveness of the convention has been evaluated for the first time in a systematic way. And since the Global Monitoring Plan is my baby, I was very proud that this program has been considered as a true success story under the convention, and it delivered the information for which it was created for. So the only thing which is now very important is that the work is carried on in a sustainable manner to support data for the next evaluations. It is, of course, under the Stockholm Convention, it's a dynamic treaty. It started with 12 POPs. Now we have 26 or 28, you know, the number changes. And it is expected that more substances will be listed. So we have trends for the substances which have been already long time regulated, but we have only baseline concentrations for those which have been listed only recently. So it's very important that we get further monitoring data. I would like to stress the importance of global cooperation and the involvement of the programs which already have been established. We call them strategic partners, and they are essential for starting monitoring work in the regions which had no such capacity. So this is one of the very important aspects, is that we have capacity building as part of the program. Another very important achievement is that all data collected under the Global Monitoring Plan are publicly available. All of them are publicly available through the reports I have showed before, but they are also electronically available through an electronic tool, which is available through the Stockholm Convention webpage. The link is there. And this is a quite friendly tool which allows also beautiful outputs and some work with the data. And just at the end of my presentation, I will show a few outputs of this survey. Since we are talking about biomonitoring, part of the GMP is the UNEP WHO Human Milk Survey, which started before the convention entered into force, and it is going on until today. And in the particular rounds, the data coverage got much improved, and what is more important is that from some points we have already several points in time of data. Here are just few outputs. All of them have been done from the database. Here you can see that you see the global picture, where data are available, what are the trends. If you click on the point in time, the database will calculate, if available, the trends over time, and if statistically not yet to be able to establish trends. At least you will see the concentrations measured in different years. The presentation is available, also the data warehouse is available, so I think my time is over. But yes, maybe this one, yeah. This is another way to show the data, and we see the sources of dioxins, and in the middle between the obvious sources of combustion, there is a young woman. And she is practicing geophagia, and that was established through the monitoring. Yeah, this is a major source of dioxin contamination, and the highest concentrations have been measured in Congo, and that's exactly due to this aspect. So through the monitoring, it was discovered, and public awareness-raising activities to prevent shown. I just would like to show the data in a context of time. The red bars show the concentrations which have been measured in the first round of the WHO Human Milk Survey. And unfortunately, somehow the titles disappeared, but the highest bar is from Belgium. And you might remember that there was a big dioxin scandal in Belgium long time ago, and then measures have been adopted, and we see clearly that the decrease of concentrations over time. So when measures are taken, we see results. Good. These are some newly listed substances like PFOS, so we will be very interested to see in the next round what will be the change in concentrations. Also HBCD, that's hexabromocyclododecan, lindane. And as I said, what is planned is that we continue, and I would like to acknowledge all the donors which made this work possible. And of course, all the in-kind support of the strategic partners and national programs. And I must say that one of the biggest donors for the global monitoring plan is the European Commission. So we have to acknowledge this, and hopefully they will continue to support that.
Thank you very much, Catarina, for this extensive and well-elaborated overview of our activities. I see a lot of links with the HBM4EU program, so I think sharing knowledge can only improve both programs. Thanks again. Are there burning questions at the moment? No? Thank you. If not, we can move to the last speaker. It's an honor to present you Michael Vader. He's specialized in human biomonitoring and exposure assessment. And since 2010, he's responsible for the human biomonitoring group and laboratory at the corporate health management of BASF. He's also working in groups dealing with analysis in biological materials, setting of limit values in biological materials, and thermal absorption. And he will share with us some insights on the added value of HBM for exposure analysis and risk assessment at work.
Perfect. Thank you very much. Yeah, ladies and gentlemen, dear colleagues, it's a great pleasure for me to be here, because I've been working in biological monitoring now for 25 years or so, and I consider myself very lucky, because when I started my PhD, I didn't expect to end up with biological monitoring throughout my whole work life. So I would like to present some of our thoughts, some of my thoughts and experience with biological monitoring. 2 years ago, we had this launch event for HBM4EU, and I already stressed out that biological monitoring is a very important, very versatile and very powerful tool for exposure assessment. And this is what I'm going to go a little bit deeper today. As I was already introduced, working for corporate health management. So that means I come from occupational medical department, and indeed occupational medicine is one of the big triggers of human biomonitoring in the industry, at least in the German industry. It's a part of health examinations. In some cases it's even mandatory in Germany to do biological monitoring. And of course it's an essential tool, as we all know, in occupational toxicology. Second one is, and that's what I'm also responsible for now, is industrial hygiene, because with biological monitoring we can see the efficiency, or we can measure the efficiency of things that we do at the workplace, like technical protection, organizational things, or personal protective equipment, so we can see if this is everything okay or not, if we have a problem there. I will go a little bit deeper into that later. And of course, in recent years, biomonitoring has also gone into consumer relevance, so of course we analyze background exposures, and we are interested in the development of method and application of methods that show us the background values of chemicals. Well, one example I would like to present to you is HBM that we are doing at our plants in my laboratory. These are, for example, steam cracker turnarounds. Every chemical installation has got a turnaround or a maintenance every few years or so, so the whole plant is dismantled. Many things are cleaned, many things are replaced, and of course if you open a plant, all these vessels, all these pipes, all these tanks, of course you can get a higher exposure. And these are some results I'd like to present from a steam cracker turnaround where we do biological monitoring top on. It's not really part of occupational and medical health protection. It's more for occupational hygiene. And if you have a steam cracker, there's a lot of benzene, of course, in there. So we do benzene biomonitoring. And you can see here the results of two HBM programs that we did during steam cracker turnarounds. And you must imagine we have samples of several thousand workers that are doing these maintenance, and you see these red dots, and see that part of these samples, like 5% or so, exceed the HBM limit value that we have for benzene at the workplace. So you see on the other hand the 2014 data, and you see there are no excursions. What have we done? Of course, we identified on the basis of human biomonitoring data the tasks and the things that the people were doing when they had these high exposures. And doing these tasks in the next turnaround in 2014, we provided the workers with additional respirators and got rid of this benzene overexposure. That is one example how we use biological monitoring in industrial hygiene. Are there added values to these things? Of course there are. Often the people ask us, well, when you do these turnarounds, a lot of workers enter your premises. There are BASF workers doing that, company workers are doing that. On the other hand, you have a lot of contractors who are doing things. Maybe you use the contractors for doing all the dirty work. And I show you here the results that we got from one of these turnarounds here, divided into company workers and contract workers, and you see that almost 90% of both groups showed results that were in the green range. From my point of view, that is below half of the action value, and you can see that the number of action value excursions is fairly comparable in both groups. So that's of course an important thing, an important answer that we can give our plant managers, with which they can talk to contract companies and of course to authorities. And the other thing is, of course, we do biomarker validations. So sometimes in the literature, new biomarkers for substances are proposed. In the case of benzene, for example, we have the standard biomarker that is often used, S-phenol mercapturic acid, and then people come up and say, well, we could as well analyze benzene in urine. So when we do these turnarounds, get a lot of samples, we try to analyze both biomarkers. We come up with this correlation that you can see here, and then we can publish or tell authorities and scientific work groups about our results, and they can decide if that's a good biomarker. In this case here, urinary benzene has been introduced in Germany as an alternative biomarker to SPMA. It's quite okay for screening purposes. It has some problems when you think about contamination of samples, but it works pretty well. Okay, and of course we also do that, for example, after chemical incidents. That is one of our main things here. We had a major incident in 2016. One of the gravest incidents in BASF history with some casualties. And of course, we also did HPM for the emergency responders, like the firefighters. And you can see here, we had 4 groups of people that were into this program. The people with this green box here, their only job was to run away from the accident site, so to go into safety. And the blue box here represents the biomonitoring results of the medical staff, so the people who went there and made first aiders. And then you see the red box, which are the actual firefighters, so the people who knocked the fire down. And you see, of course, they have a lot more exposure, but what was surprising is that the people who did the safeguarding afterwards, so the fire watch, when the fire was knocked down, and they were only watching it for 1 day or 2, stood there around and looked at that nothing else happens. These people actually had the highest exposure. Why was that? Because the firefighters, of course, always go into a fire with respiratory protection, full armor on, while the people who do safeguarding the spot normally don't do that. They don't run around with respirators. And one of the results that we have here, or one of the consequences that we draw in the future from the results that we have seen here, is in the future, fire watchers or safeguarding people will think about exposure, and they will, for example, get respiratory protection. Well, talking about benzene, this is a picture of the development of occupational exposure limits for benzene in Germany from the 1950s and 60s on. You see it fairly dropped quite a while because benzene in the meantime has been regarded, has been identified as a human carcinogen, so we have fairly low exposure limits now. This means that if we want to do biological monitoring, we also have to adapt biomarkers. We have to adapt and develop and revalidate biomarkers all the time, and this is what I would like to show here. If you want to measure benzene at workplaces at the moment, you must have biomarkers that are capable of measuring in the sub-ppm range. I mean, all this other stuff like phenol in urine or other things that have been adequate in earlier times, in these times they are no longer adequate. You cannot measure benzene exposure by phenol in urine. So the only 2 biomarkers that are currently left, from my experience and my opinion, are S-phenyl mercapturic acid in urine and benzene in urine. And you can do, of course, benzene in blood, but of course that's an invasive sampling. You don't really want that. I mean, if you talk to people, if they would prefer to give a blood sample or a urine sample, of course, they prefer the urine sample. Okay, and if we talk again about this declining occupational exposure limits, so exposure limits are constantly going down. This is what we have now. In Germany, we have an occupational exposure limit and a tolerable exposure limit for benzene of 0.6 ppm and an acceptable exposure limit of 0.06 ppm. And we have 2 concentrations of S-phenyl mercapturic acid in urine that refer to these 2 concentrations, so you can easily measure SPMA exposure, benzene exposure by urinary SPMA. But we should look a little bit in that lower concentration range, and if we do that, we see that the people below this point of 6 ppm are absolutely in the green range. That's quite okay, and all the rest is a little bit yellow, so you should be careful about that. Almost every non-smoker is well below this 2.5 microgram, but some smokers are above this 2.5 microgram SPMA per gram urine, so you will always detect smokers as potentially exposed to benzene. I mean, they are exposed to benzene, but not necessarily at the workplace, but it comes from their lifestyle habits. What we are witnessing now is that the risk assessment committee of ECHA has proposed to lower the occupational exposure limit for benzene to 0.05 ppm, and that would mean an excretion of 2 microgram SPMA per gram creatinine, which changes the picture. Non-smokers are still fairly okay, where almost half of every smoker will show exposure above that value. So we are always interested in having biomarkers that can detect background exposure. That is one of our main key drivers. Occupational exposure limits are dropping, so we need to have methods and biomarkers that are able to detect these low concentrations. And that is one reason why I'm particularly happy to be able to participate in one or the other way in this HPM4EU project. I find it very interesting, challenging, and inspiring. when we look about HBM in the scientific literature, this is a small PubMed research. You see the blue columns. There's not much going on in occupational exposure in the last 20 years or so, but environmental exposure and biomonitoring has been going through the roof in the meantime. And of course, that is interesting for us. And I show you just a short example here, what we are currently doing. Of course, we are also interested in bisphenol A. My company is one of the big producers of bisphenol A. We produce it in a tonnage band of 1,000 to 10,000 tons. In our plants, this goes mainly into polyarylethyl sulfones, so plastics. And of course, when you look at the structure, you might think that this compound may have the pretty similar toxicological issues that the compound bisphenol A has, so it makes sense to think about exposure, and it makes sense to think about human biomonitoring, although we don't have an occupational exposure limit for bisphenol S, and we don't have any biomarker limit value for bisphenol S, but if you have workers exposed to BPS, you want to know their exposure anyway. First results I can show you in comparison to some other studies. We published that on a conference some months ago in Germany. We had 142 persons, and you see the geometric mean and median values of BPS in a collective of BASF workers who were not occupationally exposed to bisphenol S, and you see it's fairly in the range of what we find in the United States and some other countries. It's interesting, for example, in Japan, that bisphenol S in your urine seems to be quite high. I don't know if you know that bisphenol A has been replaced in thermal paper in Japan more than 15 years ago. So probably or perhaps the BPS exposure in Japan goes back to that. Okay, and of course we are always interested, and I would like to point out the German BMW VCI collaboration project on HBMs. So BMU is the German Federal Environment Agency, and VCI is the German Chemical Industry Association. We've been doing that now for some years here. And what we come up with, and that is the positive aspect from my point of view, is that we come up with an aligned view on potential consumer relevance of substances and on toxicology. We develop, we publish, and we apply state-of-the-art methods. These methods and their results go into high-quality peer-reviewed publications. It's the basis for an informed toxicological evaluation, for example, for the German HPM Commission. And of course, meaningful, that means representative environmental survey data come out of that project. And of course, from an industry point of view, it shows a little bit transparency and responsible care. That's what we're always after. And the methods that we develop in the project are, of course, also applicable to workplace monitoring, and that is where I get my food from, so to say. And I think that HPM for REACH is another option. Not many biomonitoring data have gone into REACH, safe use assessment or other things, but I think this is on the upturn, and probably HPM for EU will contribute to that. So to conclude my presentation as a take-home message, it's clear, you all know that human biomonitoring is a very well-established and essential tool in occupational medicine. Knowledge of background exposure levels, as we do here at HBM for EU, is increasingly relevant for the interpretation of HBM results, even also in occupational medicine, not just in environmental medicine. And the added value, as I see it from HBM, is that we have an adequate exposure analysis tool for efficiency control in industrial hygiene, occupational medicine at the workplace. It adds valuable information for later regulatory assessment. For example, if you think about REACH, you can show safe use or not. And of course, it provides a solid basis for informed discussions between industry, regulatory, politics, academia, and NGOs, if you wish. Okay, thank you for your interest.
Thank you very much for your very nice and clear presentation. It showed a real other added value of HBM, but as you said, with clear links to the project HBM for EU, so I think we can learn from each other. So, questions, technical questions from the public? Yes, I have one there, and I have one there.
Thanks, Micha, for a very interesting talk. You showed several slides with airborne benzene levels and corresponding urinary SPMA levels. Are these based on newly developed correlations between airborne benzene and urinary SPMA, or are they calculated or extrapolated from existing correlations?
Oh, they are based on what's currently published by the German Research Foundation on the correlations between benzene in air and the biomarkers. And this correlation 0.05 ppm benzene to 2 microgram per gram SPMA in urine is from the ECHA paper, but I believe they have also taken the DFG correlations for their evaluation. Yeah, it's not new. It's published. So,
yeah, surprised because I don't necessarily agree with the values. That's why
I can imagine. Neither do I. But I mean, these values are published, so I had to take them.
Okay. Other question in the middle?
Thank you, and congratulations for your presentation and for all your work. Just a simple question. This data is covering producers or also downstream users?
The data I showed you today are only company internal data. So normally I don't analyze the downstream users. I mean, the downstream users, from my perspective, from a company perspective, downstream users are either the companies who use our products or end users, to end consumers. But I mean, as BASF, I can hardly walk around and ask people for urine samples, at least not in my town, because they will ask what is the company doing there if they are asking for urine samples. But no, it's mainly company internal data. Yeah. And all of them have already been published somewhere, either in papers or conferences.
Another question?
Yes, Catherine Gansleben from the European Environment Agency. You just almost addressed my question, because I think within the HBM4EU project, when we work with occupational exposure, we often face a lack of data. So I'm interested in to what extent you do regularly publish the data, and indeed whether there might be interest from industry side in making data from occupational studies publicly available as a basis for further research.
Honestly, thank you for the question. Honestly, I expected it a little bit. The point about occupational biomonitoring, so if you do that at workplaces, this is at least in Germany, it's deeply rooted in occupational medicine, and that means these data are medical confidential data. I cannot go around and give our individual data to any authority or to anyone. I mean, you cannot go to any health physician in town and ask for all the data of his patients. Same applies to occupational biological monitoring. We do publish data, as I already pointed out. The point is, well, it's not the core business that we do. I mean, I'm not in academia. I'm working for a company, and as much as I like to stay with one foot, so to stay in academia, I don't have the time to publish all the data in that respect. But yes, we do, and every company that has a department that visits, that interacts with academia or science, more or less publishes data. But of course there are a lot of companies that don't. So it's I know there is a demand for occupational data, and of course I'm doing these publications, but I can't do them as fast and as much as I would wish. So yeah, that's more or less the answer.
Other questions? Okay, thank you very much. So I think we had a very, very interesting morning where we saw on different levels how HBM data can, in a concrete way, be used in policy making. We started with chemical-specific risk assessment and the added value of very recent, or as much as recent, HBM results. They were really needed to proceed the process of regulation and banning. So we moved on to a more broader aspect of using HBM data, using in contaminated sites for different types of chemicals, and where we can also see if policy measures placed in those contaminated sites have the expected impact or not. With the third presentation, we moved to global monitoring, and I really remembered the plea for having comparable data so we can see a worldwide network of monitoring, and we can compare each other's data and use each other's data, ending with the use of HBM in a more professional context with professional exposure, where also was said that HBM for EU could have a real added value in developing HBM markers for low doses and for background exposure. So that was a little bit my wrap-up of this very interesting morning. If there are any comments or additions to this wrap-up, they are very welcome. And if not, I really want to ask you, bearing this knowledge inside, asking your questions through your mobile phone so they can be taken up for the discussion this afternoon. So we had some very concrete examples, but that they could lead to some more general questions which could be taken up in the discussion this afternoon. So I want to thank you all for your attendance, and I would like to invite you for lunch, I guess, in the room next door, and I think we see each other back at 1:45 sharp. Thank you very much.
If you need a taxi at the afternoon or to go to the